Hello everyone. So let's do one important question of trigonometry for class 10th board. So for board exam we are doing one important question of trigonometry. The question is cos theta minus 2 cos cube theta upon sin theta minus 2 sin cube theta plus cot theta is equals to 0. So we have to prove LHS is equals to 0. So let's start the solution. LHS. Let's copy down the LHS. LHS is cos theta minus 2 cos cube theta upon sin theta minus 2 sin cube theta plus cot theta is equals to 0. Clearly what I can do is I can take common cos theta from numerator and sin theta from denominator. Let's see what we will get. If I take common cos theta in numerator, here we are left with 1 minus 2 cos square theta. From denominator I am taking sin theta common, so the first term will be 1 only, 1 minus 2 sin square theta plus cot theta is equals to 0. Okay, because this so we have to prove, so we will not write this equals to 0. We will just erase this because we have to just write down LHS only. So while we are doing the LHS, so what we have to do is now always take an I on RHS. In RHS we have to prove it equals to 0. Cos theta upon sin theta will make cot theta. So we have cot theta in the numerator. Here we are left with 1 minus 2 cos square theta upon 1 minus 2 sin square theta plus cot theta. See, here we have already cot theta, here we have cot theta. If somehow any of this term will become 0 and this will be of negative, then cot theta minus cot theta will give you 0. So what I have to do is I have to solve this. Leave this cot theta as it is. Okay. Now in numerator we have cos, in denominator we have sin. So let's try to convert both in the same. Leave this 2. We know one identity, I am writing it here. Sin square theta plus cos square theta is equals to 1. So from here, if I'll find out the value of cos square theta will be 1 minus sin square theta. This identity I am going to write here. See children, whatever identity you are using, at the same step you have to mention that identity. So in place 1 minus 2 I have taken common, there is left only cos square theta. In place of cos square theta I am writing 1 minus sin square theta. And what is in denominator? 1 minus 2 sin square theta. Now in next step what I am going to do is I am going to just open the bracket. Cot theta 1 minus 2, 2 is outside the bracket. Let's multiply this 2 with 1. 2 into 1 is 2. Now what I am going to do is this 2 I am going to multiply with this sin square theta. Minus will give you plus. So minus will become plus. 2 into sin square theta will give you 2 sin square theta upon 1 minus 2 sin square theta plus cot theta as it is. Okay, let's move further. Cot theta 1 minus 2 will give you minus 1. So this will be minus 1 plus 2 sin square theta upon 1 minus 2 sin square theta plus cot theta. Now see, here it is minus 1 plus 2 sin square theta. In denominator we have 1 minus 2 sin square theta. It means from numerator if I take minus sign common, I am taking minus sign common from these two terms. If I take minus common, so what is left here? Here we are left with plus 1. Okay, and if I take common from here minus, we will left minus 2 sin square theta. Means if I am taking minus common from the numerator, the sign of the bracket will change. It was minus 1 plus sine square theta. It will become 1 minus 2 sine square theta. And in denominator we have 1 minus 2 sine square theta plus cot theta. I think now the solution is visible to you. This will cancel out with this. Now we have minus cot theta plus cot theta, minus cot theta plus cot theta. Two things of the same sign will cancel out and our answer is 0. That is the RHS which we have to prove. So this is the solution. So this is the solution of the equation. Okay. Thank you.